Howdy, today on Flipping Science we're going to look at drawing electrochemical cells. So an electrochemical cell, a simple galvanic cell, is a battery, and they're made up of two half cells, and that's what we're going to focus on drawing today. In order to figure out how to draw the half cells, you need to know some information about the reactivity of the components inside the half cells, and also things like solutions. They can help you out as well. You need to be able to figure out which side is going to be the reduction side and which side is going to be the oxidation side. So let's do some example questions. So in this question it says you have a metal activity series here, so we've got calcium being the most reactive, cadmium being the least reactive. It says the diagram represents a cell setup. We've got magnesium and nickel. You need to label the electrolyte, anode, cathode, salt bridge, direction of ion flow in the salt bridge, and direction of electron flow in the cell. And then write suitable equations for the reactions occurring and classify them as oxidation and reduction. So let's get started with that. So the first thing we're going to do is do our labeling, and then we'll do the equation. So we'll start with the electrolyte. The electrolyte is just the solution that's inside. We weren't told in the question what the solutions are, but they're solutions of magnesium-nickel solutions. Okay, so inside this side we're going to have magnesium 2+ aqueous. And over here we're going to have nickel 2+ aqueous. Okay, so we've labelled the electrolyte. Now we need to determine which side is anode and which side is cathode. So if we go back to our activity series that we're told here, we're told magnesium is more active than nickel. So the more active metal is the metal that is oxidized, and the anode is the electrode where oxidation occurs. So our magnesium side here, so this is going to be our anode. That means the nickel, so it's less reactive, so it's going to be reduced, so the nickel ions are going to be reduced. So the site of reduction is the cathode. So this is going to be our cathode over here. Alright, salt bridge, so here's the salt bridge in the middle. Then we need the direction of ion flow in the salt bridge. So there's going to be a positive ion and a negative ion, and we need to determine which side they go to. So as the magnesium over here is oxidized, you get an increase in concentration of magnesium ions in the solution, in the electrolyte. That makes this gives it an overall positive charge. So to get rid of that overall positive charge, that means the negative ion in the salt bridge has to go in that direction into the magnesium electrolyte. Over here at the other side, we're going to get an increase in the negative ions as the nickel ions are reduced to solid nickel. So it's going to get an overall build-up of negative ions in there, so the positive ion has to go in that direction. We also need to do the direction of electron flow in the external circuit. In our galvanic cell, it goes from anode to cathode. So we're getting a whole heap of electrons being generated down here. They don't like each other, they repel, so they move away from each other through the external circuit in that direction. So the electron's going this way, and then the electron's going that way. Okay. The last part of the question says, write suitable equations for the reactions that occur in each half cell and classify them as oxidation or reduction. Okay. So at our anode, we've got our magnesium that's being oxidized. So we're starting with magnesium, and oxidation is loss, so the magnesium is losing 2 electrons. And the magnesium is going into solution as magnesium ion, so it's going in as aqueous. So that means that at our nickel cathode over here, the nickel ions are being reduced. So nickel 2+ aqueous, so the ions are being reduced, they're gaining electrons, and you're making a solid nickel. So the nickel ions are coming out of solution, they're being reduced to solid nickel metal. Now we need to identify which one is oxidation. So in this case the magnesium, oxidation is loss, so that's oxidation, and the nickel ions are being reduced. So here's our second example question. So we've got a voltaic cell constructed from a half cell in which cadmium, so I'm going to highlight some important bits as we go through. So we've got a cadmium rod dipping into cadmium nitrate, so that's our electrolyte on that side. On the other half, we've got a silver rod, and that's going into silver nitrate. So that's important information to know so we've got what our metals are and our electrolytes. Two half cells connected by a salt bridge, so that's good to know. And the silver ions are being reduced. That is very important. So the silver is being reduced. That means that the cadmium has to be oxidized. So draw a sketch of the cell, label anode and cathode, write half reactions, indicate electron flow and sign of the electrodes. So let's do that now. So here's my diagram. I've hooked up a voltmeter. So first bit of information that we were told that's very important is the silver ions are reduced. Now I like to have the oxidation half cell on this side and the reduction half cell on this side. So I'm just going to label that quickly. So that side is going to be ox and that side is going to be red. So the silver ions are reduced. So if we look back at our information, we're told that there's silver nitrate is our solution down here. So we've got our electrolyte is AgNO3, and on the other side we had cadmium nitrate. Okay, now silver is being reduced, so we know the site of reduction is the cathode. So this is our cathode, and consequently the cadmium is being oxidized, so that's our anode over here. We're going to get a buildup of electrons down here as the cadmium is oxidized. So a buildup of electrons gives you a negative charge. So the anode is going to have a negative charge. The cathode is going to have a positive charge. What else do we need to know? Let's look back at our question. We'll do the half equations in a second. Direction of electron flow. So buildup of negative charge on this side, so the electrons are going to be pushed away. So our electrons are going to move from the anode to the cathode, like that. And now we can write our half equations. So our cadmium rod, so the rod there is made out of cadmium. Over here we have our silver rod. The cadmium is being oxidized. So oxidation is loss. So cadmium, so solid cadmium, that's going to cadmium ions, Cd2+, and that's aqueous. And plus 2 electrons, so it's losing the electrons. Over here the silver is the site of reduction, so the silver ions are being reduced from the solution. So Ag plus aqueous, that's dissolved in the solution, plus 1 electron, because silver only has a charge of +1, goes to solid silver, so Ags. If we wanted to, we could then write the overall equation by timesing this one down here by 2, so we have the same number of electrons in both sides. And then we'd be cancelling out the electrons. So we'll just write that out quickly. So we've got 2Ag plus aqueous, so it's 2 silver ions in solution plus 2 electrons goes to 2 solid silvers. Now we can write the overall equation if we like. So we'll cancel out the electrons which are on both sides of the arrow. So we've got cadmium solid plus 2 silver ions in solution goes to cadmium ions in solution plus 2 solid silvers. Alright, so there's some example electrochemical questions. That's it for Flippin Science today. See ya.